Hi everyone, it's Math with AUB. Some questions for the preparation of a NAT. Mostly ECAT type questions are present. I have undemarcated the line of first year and I have written some questions in mixed type branch, Sunday type branch. Without wasting time, our question number one. Our question number one is the definite integral O to pi upon 4 sine square angle 2x dx. Sine having even power. When sine or cosine having even powers, we always utilize the trigonometric identities. Sine square x is equal to 1 minus cos 2x over 2, while for cos square x we utilize the identity 1 plus cos 2x over 2. When at the outset sine and cosine, either sine or cosine or sine and cosine have even powers, might be power 2, 4, 6, 8, 10 and so on. When sine and cosine have even powers, we utilize these two identities. Sine square x is equal to 1 minus cos 2x over 2 and cos square is equal to 1 plus cos 2x over 2. Before solving these questions, let's see a demo of this one. Even if a mixture of these two present, sine square x times cos square x, both have even powers, we utilize the same identities, sine square goes as is equal to 1 minus cos 2x times divided by 2 times cos square means 1 plus cos 2x over 2 dx. A delicate, a fine situation of a negative ba minus b difference of 2 square situation. 2 to the 4, let me write 4, 1 over 4 outside. 1 minus cos, 1 plus cos, it will become 1 minus cos 2x, 1 minus cos 2x times 1 plus cos 2x dx. Working diligently and proceeding, we have 1 square minus cos square 2x dx. Now we multiply 1 upon 4 and dx, add this integral symbol to each term. 1 upon 4, 1 times dx, negative 1 over 4, we have cos square 2x dx. 1 upon 4, integration of 1 is x. Look here, again we have same situation, cosine having even power, again we utilize the same formula as 1 over 4. It is 1 plus cos, double the angle, cos square x, there is 2x, there is 2x, double the angle, here cos 2x, it turns to be 1 plus cos 4x divided by it. Cos square 2x making the angle double, 1 plus cos 4x over 2. 1 plus cos 4x over 2. Making some space for myself, making some room for the solution of the question. We have 1 over 4 x, it will become 2 for the 8, I am writing outside. Integration of 1 dx and integration of cos 4x dx. We have some situation like this, 1 upon 4x minus 1 over 8, integration of 1 is x, integration of cos is sine 4x, dividing with the derivative of the angle, that's 4 plus c, multiply negative 1 over 8 throughout, 1 over 4x minus 1 over 8x, negative, positive, negative, 8 4 the 32, sine 4x plus c. Taking LCM of this one as 8, it will become 2x minus x minus 1 over 30 sine 4x plus c. It will become x over 8 minus 1 over 30 sine 4x plus c, sine 4x plus c. That is a simple background why to utilize these identities, because these utilize turns even powers to powers of 1 in cosine, and it is really very easy to integrate cosine having power 1. It is really very easy to integrate cos having power 1. Okay, now coming back to our actual question, that we have treaded some path in order to get some idea utilizing the formula. Now we start our major work to solve this question. We have this question. Limits are 0 to pi over 4 sine square 2x dx. Utilizing this identity, keeping this thing in mind that there is x, there is 2x. Double the angle. It question turns to be, if we flip this formula to here, it will become 1 minus cos 4x over 2 dx. Writing 2 outside as 1 over 2, it is in denominator, 1 minus cos 4x times dx. Lingering on the limits of 0 to pi upon 4, 1 over 2. Integration of 1 is x. Integration of cosine cos 4x is sine 4x, dividing with the differentiation of the angle, that's 4 plus c, and putting the limit upper and lower limit. That's the way, that's the style to put limit, upper limit minus lower limit, upper limit minus lower limit, upper limit minus lower limit. Writing this complete function same, first instead of x insert plug in pi over 4, then write same function, instead of x plug in 0, that's putting upper limit minus lower limit and getting some wonderful answer, 1 over 2. X means pi over 4 minus 1 over 4 sine 4 times pi over 4 plus c. That's our upper limit. That's our upper limit. What about lower limit? Minus 1 over 2. Lower limit is 0, x 0. Sine 4 times 0 is also 0 plus c. Pi upon 4, 4 cancel. Sine pi, sine 180 is equal to 0. Sine 0 is 0, that's 0. Nothing is left, only these two terms. 1 upon 2 times pi upon 4. So our answer turns to be pi over. Our answers turn to be pi over 8. That is the limit pi over 4 we have finally, and 1 upon 2 from this formula. 1 upon 2 from this formula. 2 times 4 is 8, pi upon 8 is our right answer in that case. It is the way, it is the path, it is the mode to deal with the integration of sine and cosine having even powers. Sine and cosine having even powers. These are the two magic identities worked wonder for you in trigonometry itself as well as integration, while especially negotiating the integration of sine and cosine having even powers. Moving towards next question, it's read as differentiation of a square minus x square plus a times sine or sine x over a is equal to what? Differentiation of a square minus x square in the square root plus a times sine inverse of x over a. We have to integrate this one. How to deal the differentiation of square root? It's really very easy, really very cool concept. Let me shed some light on this. A square minus x square, differentiation of the square root function. Differentiation of the square root function. Simply mind hack, write 1 over 2 whatever is in the denominator in upon. 1 upon 2, this term same. 1 upon 2 whatever the function is, write in the denominator. 1 over 2 whatever the function is, write in denominator. Now whatever is inside the function, whatever is present in the square root, differentiation of this function here times the differentiation of this inside function, that is differentiation of a square is 0 and negative x square is 2x. So we have 1 over 2 times a square minus x square times negative 2x. Cancelling out 2 and 2, we are left with x negative x over a square minus x square. That is the way to negotiate the integration or differentiation of a square minus x square. Mind hack, 1 over 2, whatever is in square root, right in the denominator, and whatever is inside the square root, its differentiation must be present in the numerator. A square is 0, x square is 2x. Or you can take the orthodox method by dragging the power down, subtracting 1 from the power and so on, like as this. A square minus x square, square root means 1 over 2. Its differentiation is given by, make the power coefficient, subtracting 1 from the power that we have dealt with power. Our power is 1 over 2, drag the power down, make the power coefficient, subtract 1 from the power, we have dealt with power. What is our base? That is a square minus x square. Its differentiation must be written in multiplication in the very same step. Differentiation of a square is 0, negative differentiation of x square is 2x. That is the differentiation of base. That is the way to deal power base. 1 upon 2 minus 1, we are going to have a square minus x square is negative 1 over 2 times negative 2x. To cancel out, make this exponent positive, drag this quantity into denominator, we have negative x over a square minus x square is 1 over 2, or negative x divided by a square minus x square. That we have already concluded. That is the way of finding the differentiation of this under root. How to deal sine inverse? Differentiation of sine inverse is written as differentiation of arc sine is given by 1 over 1 minus x square. Normally in our books this formula appears, but whenever it is present in the exam or at good level in good situations, there must be a multiple of any real number is present here. There is not simple x. So it is perplexing, baffling, obfuscating the reality. One cannot apply formula here if to the utmost effort of a student write x over a instead of x, but he hasn't managed the differentiation of this as 1 over a, and he is going to fall definitely. So mind formula I used to teach students as sine inverse. I write instead of x angle, and mind formula is 1 over 1 minus angle square times differentiation of angle. That is my extra tip to you as well. Treat x as angle square, then don't forget to differentiate the angle. That will give us 1 over a, and it works wonder for us. So differentiation of this to be sine inverse x over a, we have something like 1 minus angle square. Our angle is x over a square. Differentiation of angle, it will become 1 over a. Then we are going to land at safe zone, comfort zone, and we arrive at the result very easily. Now let's see both these differentiation of square root as well as arc sine collectively together. It's really very easy. First, I have broken down both concepts for you in order to explain to you. Then to solve this as they are given, as they are embedded, as they are joined together, I have under root a square minus x square. This one can be written in the denominator. 1 over 2 under root a square minus x square. 1 over 2 under root a square minus x square. Whatever is in the square root, write in 1 upon 2 times that function. Whatever is inside that function, inside that square root, differentiate. A square is 0 minus x square is 2x plus a same sine inverse, as I have already told you, 1 minus angle square. Don't take x, angle square. Our angle is x over a whole square times the differentiation of angle. Differentiation of x over a is 1 over a. A here cancelled out, as well as 2, 2. We are left with minus x over a square minus x square plus 1 over. Open this up, it will be 1 minus x square over a square. Simplifying this one, we have minus x times a square minus x square plus 1 over a square minus x square over a square. It is a perfect square quantity, a square. It will come out of the denominator, out of the square root. It will become a. It will become a like as this, minus x over a square minus x square plus 1 over a square minus x square over a. Owing to the property of double division, a will be in the numerator. We have minus x over a square minus x square plus a times a square minus x square. Denominators are homogeneous. Write one time denominator, no transition in the numerator. We have a square minus x square, that is negative x plus a. If I write this one as a minus x and factorize the quantity present in the square root, that is a minus x times a plus x. It has power 1, it has power 1 over 2. Applying table, I have a minus x as well as a plus x. It is already in the square root. That's our answer. That's our answer. Don't get yourself tumbled over by this step. Let me explain to you. A minus x divided by a minus x. It's up to you, rationalize, or both have same base. Subtract 1 upon 2 from 1. I am going to have 1 minus 1 upon 2. That is 1 over 2. Or I can write a minus x. Or if you have still confusion, let me make it more simple. X over under root x can be written as under root x by just subtract 1 upon 2 from 1 or rationalize. Even same x root x over x, it also result, it can be written as 1 over root x, 1 over root x. Owing to the same concept, rationalizing or subtracting 1 upon 2 from 1, 1 upon 2 from 1. It's up to you. Whatever you want to understand. All these paths are equivalent. They are leading to the same result. Under root a minus x, there is under root a minus x. 1 over 2, 1 minus 1 over 2, we are left with 1 over 2. I have written in the same square root in order to facilitate my work and save the step. So option number A is the right option in that case. Moving towards next question, we have the next question. Find the shaded region. It's really very simple. But what are these four options that are written? Let me give you a simple idea about set theory. Let me be a George Cantor for a while. The concept mostly says A intersection B is equal to null set. Then what is the relation between A and B? What is the relation between A and B? I am giving you overview of some set theory. A intersection B is equal to null set. Then A and B are mutually disjoint. A and B are called mutually disjoint. Mutually disjoint. Mutually disjoint means their intersection is always null set. Their intersection is always null set. They are not overlapping set. Not overlapping set, or one can say not overlapping. Not overlapping means nothing in common, not overlapping sets. Their diagram must be like this. A and B have nothing in common. A and B have nothing in common. Such type of sets are known as mutually disjoint, or in loose terminology you can say non-overlapping, not overlapping, non-overlapping. Let me give you example as well. This is suppose odd number is 1, 3, 5. 7, and so on. Taking even, 0 is also even, 0, 2, 4, 6, 8. They have nothing in common. They have nothing in common. So we can say that set of even integers and odd integers, they result in null set. These sets are mutually disjoint. These sets are mutually disjoint. Mutually disjoint. If two or more than two sets have nothing in common, these sets are known as mutually disjoint. They are known as mutually disjoint. They are known as mutually disjoint. Okay, then here. That is associative law. You must be familiar. A intersection B intersection C. Both sides have A intersection B intersection C. Where lies the point of difference? Where lies the point of difference? Try to understand. Here, bracket encompasses A and B. A and B. Here, bracket encompasses B and B. It means that it is going to start from very left and it is going to start from very right. Very right. First compile A intersection B. Whatever the result is, find the intersection with C. Start from bracket. First simplify the bracket. First find A intersection B is starting from extreme left. A intersection B, whatever the result is, then intersection with C. It starts from left. And this one, first find B intersection C, then with A. Then with A. Starting from the very right. This is known as associative law for intersection. Associative law for intersection. Associative law for intersection. Associative law for intersection. Similarly, in the same token, if instead of intersection there present union, A union B union C is equal to A union B union C, again bracket to BC, bracket belongs to A and B. It must be start from extreme left. First find the union of A and B, then with C. In that case, first find the union of B and C there. It is known as associative law for union. Associative law for union. Associative law for union. Associative law for union. And finally, let me give you a good example of distributive law. A union B, here is intersection C, or A intersection B union C. Look at this. In associative law, both symbols are identical. Intersection, 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 intersection. While in union, there is also union. There is a difference. Union, there intersection. Here intersection, here union. It reads as distributive law of union over intersection. This reads as distributive law of union over intersection. Union over intersection. And this one reads as distributive law of intersection over union. Intersection over union. Intersection over union. It is union over intersection, and here it is intersection over union. How to write its right hand side? It's a not. Look at this. Like multiplication, ordinary multiplication. Write A union B, A union instead of in front of B as well as in front of C. Write A union in front of B as well as in front of C. Write A union in front of B as well as in front of C, like as this. A union B and A union C. This bracket, this symbol remains intact. It's our intersection. This is our distributive law of union over intersection. Union over intersection. Similarly, put A intersection in front of B as well as C. We have A intersection B and A intersection C. A intersection C. This union remains intact. This is known as distributive law of union over intersection. This is distributive law of union over intersection, while this one is distributive law of intersection over union. Intersection over union. And let me finalize this one and moving towards the question after finding, after explaining De Morgan laws. De Morgan laws. De Morgan laws. De Morgan laws. De Morgan law states that De Morgan laws. Then coming back to the question, original question, De Morgan laws. De Morgan laws. A intersection B whole complement. Let me write C. Its tantamount to A complement union B complement. While the second law is A union B whole complement is equal to A complement intersection B complement. I used to write MCQs collect joining them together as A union B intersection C whole complement. The combination of both De Morgan laws. The combination of both De Morgan laws. Individual complement, union turns to be intersection, intersection turns to be union. A intersection B complements, union C complement. That is equal to this one. The simple application of De Morgan law. De Morgan law. Now our question says that we have given a Venn diagram of three sets, that is, and they have shaded this common portion, this very common portion. That is the portion that belongs to A as well as B as well as C. This is the overlapping portion of all these three sets, all these three sets, all these three sets. It is known as A intersection B intersection C. We have given a shaded portion here. Look at this. It is common to A, common to B as well as common to C. Common to A, common to B as well as common to C. This is our A intersection B intersection C. That is common to all. 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 That is our A intersection B intersection C. Let me share with you how to find, how to apply union and intersection for two sets or three sets. How to find their elements. It's really a cool concept. Number of elements in A union B is equal to number of elements in A plus number of elements in B, subtracting the overlapping elements. Subtracting the overlapping element. That is for two sets. If there are more than two sets, it's a wonderful concept. A union B union C. It means in a number of elements in all three sets. It's equal to number of elements in A plus number of elements in B plus number of elements in C, subtracting intersection of AB, BC and AC. 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 Subtracting the overlapping portion. A intersection B minus B intersection C minus A intersection C, and restoring the intersection of all these three and number of elements in A intersection B intersection C. This is for three sets. Three sets. How to find their number having in both A and B, in BC, in AC, or in all. That is the application of sets theory. Number of elements in AB or in A, B, and C in a real life. Moving towards next question, we have. Moving towards next question, it is based on analytic geometry. Circle, x square, y square, they are both positive, having same coefficient. No doubt it is equation of circle. We are asked to find its parametric equation. We are asked to find its parametric equation. Normally, we take a special case of circle having center at origin. It has parametric equation as parametric equations. X is equal to r cos theta and y is equal to r sin theta. It's really very cool. Whatever the radius is, just replace here and we manage the situation. But in that case, they have given an equation having not center at origin. Having not center at origin. How do we come to know that having it says this circle has center at origin or not? Look at this. There is no term involving x power 1 and y power 1 is present. No term having x power 1 and y power 1 is present. If in equation of circle there is no term having x power 1 and y power 1, simply it has center at origin. While in that case we have a term having power 1, 4x, it is present. It's understood that it has not center at origin. So we need the center as well as the radius of this circle. We need the center as well as the radius in order to get to the parametric equation of the circle, that's r cos theta and r sin theta. What we have given? X square plus y square plus 4x plus 2 is equal to 0. First, write this equation in that form, x minus a whole square in standard form, y minus b whole square is equal to r square. Then it's really very easy to take polar parametric equation in that. Instead of x, take x minus a is equal to r cos theta. Instead of y, take y minus b is equal to r sin theta. R1 can write these two equations as x is equal to, shift a here, r cos theta plus a, and y is equal to r sin theta plus b plus b. So the situation is prevailing here. That's the case. We have to convert this equation either into this or taking directly coordinates of center and finding the radius and inserting here. Check both possibilities. X square plus 4x plus y square, shift constant on the other hand side. Make this one as perfect square. X square plus 2 times x plus 2, there must be 2 square plus y square. Adding this quantity on both sides, to make it perfect square. Now it is a perfect square of x plus 2 whole square, and here is only y square minus 2, square of 2 is 4, minus 2 plus 4 we have x plus 2 whole square, y square is 2. Transforming this equation into this, we have x plus 2 whole square. Instead of y, I can write y minus 0 whole square. Instead of 2, I can write root 2 square. Now I can take x plus 2 instead of x, and I take y instead of y in that case, and that's my radius. Taking x, I have x plus 2 is equal to r cos theta. X plus 2, mine r is 2 in that case, root 2 cos theta. X plus 2, as in option number 1, shift 2 here, we have under root 2 times cos theta minus 2, and in case of y, I have y is equal to root 2 sin theta. There is 0, there is no need to write 0 here, I'll shift 0 here. That is my parametric equation in that case where the center is not at origin. If the center is not at origin, then switch over to this. Whatever is this, take x minus a is equal to r cos theta, and here y minus b is equal to r sin theta, where a and b are the coordinates of the center, where AB is the center of the circle, In that case, mine option is A. Moving towards next question, we have, let me find a storm in the teacup. In that case, we have given 1 to 3 definite integral function of y, independent variable is y dy. Okay, normally what we have, a to b f of x dx. From our elementary calculus, we are finding its area under the curve. Let me suppose here is a, here is b. AB is on x-axis. F of x has been plotted. Suppose that is the graph of our function. We are interested in the area under the curve from A to B. Here is x, and limits belongs to x, and limit belongs to x. It is the normal case. And in our case, he has turned down the situation, x to y, y to x. Here independent variable is y, and dependent variable is x. To draw sketch for this, it is something 1 and 3 can be drawn. 1, 2, 3, that's R3, these are the limits. X-axis works, y-axis. Whatever is x here, A to B, in that case it is y, and the graph similarly here. So we are interested in this. finding the area, this, finding the area in this. In nutshell, these limits belong to Yx. In nutshell, these limits belong to Yx. In that case, a and b, normal case, f of x, independent variable is x, independent variable is x, x. These limits belong to integration limits belongs to x, and in that case, independent variable is y, independent variable is y. So these limits belong to Yx. So this limit belongs to Yx. That is the value of y in that case, or upper limit or lower limit, or upper limit or lower limit. It's my tiny effort you guys explain to you the question in depth in order to understand. My slogan is that clarity, simplicity works wonderful. It's all by itself. Next.